Gravity is what causes an object to accelerate towards the Earth at a constant acceleration of 9.8 meters per second squared. We have learned in past lessons that in free fall x equals 1/2 gt squared, with x being the distance from which an object fell from and t being time. As the paper fell for 2.15 seconds, we can, using that formula, deduce that it fell from 22.7 meters. However, the paper fell from 1.5 meters from what we measured. Human error can only amount to so much. And the time we calculated is quite accurate due to us greatly reducing the error from reaction time. Therefore, some other force is at work. That force is air resistance. We can calculate that force, the force that air resistance exerts on the paper, by reusing the equation x equals 1/2 gt squared. Except now, gravity is a, acceleration. You would then get 1.5 meters equals 1/2 a, parentheses, 2.15 seconds squared, parentheses. Acceleration would then be 0.648 meters per second squared. From Newton's second law, which we learned in the past and can apply now, acceleration is net force divided by mass. The acceleration is 0.648 meters per second squared, and 0.0045 kilograms is the mass we measured. 0.648 equals net force divided by 0.0045. So net force is 0.0029 newtons. On an object in free fall, as horizontal components do not affect vertical components, the weight must be what pulls an object toward Earth, and air resistance the opposing force. Weight is mass times gravity. Weight then is 0.0441 newtons. By subtracting the net force, 0.0029 newtons, we get 0.0412 newtons as the force air resistance exerts on the paper. The air resistance is especially large as it is directly proportional to the surface area of an object, and a piece of paper is very wide. As the eraser is not nearly as wide and large as the paper, we can expect the acceleration to be much closer than 9.8 meters per second squared. The eraser fell from 1.5 meters, and for 0.1571 seconds, we can get the acceleration of 9.201 meters per second squared, a little short of gravity. 9.201 equals net force divided by 0.0045 because acceleration is net force divided by mass. Net force then is 0.0414 newtons. By subtracting that from the weight, we get that air resistance exerts 0.0027 newtons on the eraser. The eraser is not an equilibrium because equilibrium means that all the forces acting upon an object add up to zero. As there is a net force that is not zero, the net force is 0.0414, the eraser is not an equilibrium. Of course, these numbers are most likely not accurate due to rounding and measuring errors. However, it is more accurate than it could be, as reaction time is, again, not as much of an error due to the slow motion.
Thanks for watching, guys!